section 1.4, Other Effective Sampling Methods. In the last section, we learned about simple random sampling. Now we will learn about the remaining three: stratified sampling, systematic, and cluster sampling. So what is the goal of sampling? It is to collect as much information as possible about the population at the least cost. So let's figure out how to obtain a stratified sample. You do this by dividing the population into non-overlapping groups called strata, and then obtaining a simple random sample from each stratum. The individuals within each stratum should be homogeneous. That means similar in some way. So let's look at an example of a stratified sample. Suppose Congress was considering a bill that abolishes estate taxes. In an effort to determine the opinion of her constituency, a senator asked a pollster to conduct a survey within her state. The pollster may divide the population of registered voters within the state into three strata: Republican, Democrat, and Independent. This grouping makes sense because the members within each of the three parties may have similar opinions regarding estate taxes, but opinions among parties may differ. The main criterion in performing a stratified sample is that each group stratum must have a common attribute that results in the individuals being similar within the stratum. Let's work on our own example. So let's go back to this one. Like it said, the Republican, Democrat, and Independents, this grouping makes sense because they probably have the same opinions within each group. So then if you sample individuals within each group, you should be able to come up with a good idea of the survey. Okay, so the president of DePaul University wants to conduct a survey to determine the community's opinion regarding campus safety. The president divides the DePaul community into three groups: resident students, non-resident students, and staff, so that he can obtain a stratified sample. Suppose there are 6,204 resident students, 13,304 non-resident students, and 2,401 staff, for a total of 21,909 individuals in the population. What percent of the DePaul community is made up of each group? So for the resident, we would take the total of residents, so 6,204, and divide that by the total amount to give us 0.28 or 28%. A non-resident would be 13,304 divided by 21,909, giving us 0.61 or 61%. And then staff. Giving us 0.11 or 11%. The president wants to obtain a sample of size 100 with the number of individuals selected from each stratum, weighted by the population size. How many individuals should be selected from each stratum? So this these are not the same proportions. So we're not gonna survey 33 residents, 33 non-residents, and then 34 staff. You need to do it proportional to the proportion of each. So you're going to take 28% times 100 to get the amount to survey for a resident. So 100 is a nice number to see, but just know that if it was 75, you would put 75 here to come up with your number. Okay, non-resident, 0.61 times 100 equaling 61 non-resident students, and then staff, 0.11 times 100, which would give you 11. If you add these up, they should equal to 100, which is the sample size. And if you add these up, this should always add up to 100%. To obtain a stratified sample, construct a simple random sample within each group. So what you could do is, for the resident, there should be 28 unique numbers from 1 to 6,204. Then for non-resident, there should be 61 unique numbers from 1 to 13,304. And then for staff, there should be 11 unique numbers from 1 to 2,401. So what are some advantages of stratified sampling over simple random sampling? Well, because we can, in Stratify, we can get them in groups. This is an advantage because researchers can determine characteristics within each stratum group.